All right. Microphone doesn't want to quite stay on. All right, see where we're at with Twitch. If it's coming through yet. I transferred my computer into a case over the weekend and thought I fried my motherboard. So, turns out I didn't, thankfully, but it's like everything's brand new and untested in this new environment. Alright, Twitch looks good. Maybe a little choppy. Alright. So for this code kata, we're going to go through the strategy pattern. Same principles as before, where I've got Trilio and a few steps defined here. And then I also have a C# project that I will be coding on. Clear up all the using statements we're not going to be needing. Right, and as usual, it's good to look at what the strategy pattern's definition is. In this case, it's going to be define a family of algorithms, encapsulate each one, and make them interchangeable. Strategy lets the algorithm vary independently from clients that use it. This is probably one of the more obscure lexicons that you're going to find for design patterns, and I think this probably leads to a pretty low rate of adoption. But essentially, the strategy pattern is a behavioral pattern that really tries to target things which would change at runtime, which is a pretty important distinction to make because there's another pattern called the bridge pattern, which is a structural pattern that feels almost identical. And the real difference between the strategy and the bridge pattern is, again, the strategy is something that we want to use if we're changing behavior at runtime, and the bridge pattern is something we want to use to really structure out that implementation. So they're very closely related, and you'll see a lot of arguing online about what the actual differences are. So let's go back over to our kata. And we will be doing the bridge pattern in a few weeks, maybe next week, to show where it's useful and how it relates, and then also where it picks up in terms of structuring our code, where the strategy pattern leaves off. So our first step, as always, is to create a Git repo or burn off the old one. We have one already started, and just like the last pattern, if you come to my GitHub, there's a link in the channel, you will see the strategy pattern kata. So if you want to follow along, it's there for you. Alright, so you've got that, success. Create a simple UI. It feels redundant, but we just want to do it every time. Alright. It ran. Let's go ahead and throw in a console.read key just to stop it. Hello world. That works. Let's go ahead and commit our first step. Create a simple UI. And commit. Sync it up with GitHub. And if you're new to C# and you're coding along, or you're seeing this on YouTube in a few weeks, you can go on to GitHub now and grab this commit, and it'll be right where we are. Alright, so create a simple UI. And done. Alright, and the next step is to create or select a suitable entity. So we want to think for a second about what would benefit from a runtime change in behavior. A great exercise that comes along with practicing these strategy pattern katas is figuring out how to model things, like anything in life, right? So last week we did the factory pattern, and we used a vehicle. So there's a lot of things that could apply to a vehicle, like for a truck. If you wanted to do a towing capacity, is maybe a behavior that's going to change depending on the current state of the truck. So the new, and if I alienate anybody with the gearhead stuff, I apologize, but the 2015 Suburban has this very fancy V8 engine that'll go down to 4 cylinders under certain conditions, right? So depending on what the state of the car is, your towing capacity could change, and that's a runtime condition, right? So if you're low on gas, if you're running in 4 cylinders, if you're in a hybrid, all these things are going to be taken into account in the moment, and the strategy for towing capacity could change. It's maybe a very particular example, but is an example of how that strategy and that behavior at runtime makes it a candidate for the strategy pattern, and not necessarily for something like the state pattern or maybe some of the other behavioral patterns. So we're going to choose, on the drive home from work today, I thought maybe an outfit picker. And that sounds weird, but it lets us give suggestions based off of the weather, which is something that you might be taking in and consuming an application and hoping to change the behavior of your website or your application based off of some sort of environment change. So let's go ahead and we'll add a folder. I'm just going to call that domain. We're going to add another folder. And unlike the factory pattern, we're starting at a lower level of implementation, so we can get kind of right into the nitty-gritty. So for my domain aggregate, I'm just going to call it a just outfit. So pretty simple concept, being that I'm writing a web app or something like that, and what I want it to do is give me a recommendation based off of what the current weather is. So I'm going to go ahead and do a new item in the root of my domain. I'm going to say weather types. I'm just going to say rain, overcast, snow, sunshine. Nothing too crazy. And for our, we might change this in a second as we're thinking through it, but for the abstraction, let's go ahead and call this what's called outfit as well. I'm going to rename this to something a little more generic. Let's call it weather. Let's go ahead and move this into weather. And we are refactoring early. Alright, so refactored types is now in our weather, and we've got an outfit. Okay. Next, we want to define an interface for our strategy. So we do an item, and we're going to say outfit strategy. So what we're doing here is we're going to have our outfit go ahead and refactor that as well inside weather. So we've got our outfit, so in public class, and one of the things we're going to have is an outfit strategy. We've got private, we'll call it outfit strategy, and the outfit strategy is what we're going to call for some of our public-facing methods. So for an outfit, let's just say we want to recommend, we'll return a string. Let's call it footwear. So this will give you the idea of what we're hoping to accomplish in terms of our strategy. So the concept is I have an outfit and I want it to give me a recommendation on footwear based off the weather. Pretty simple, and we should be able to create a new outfit class and pass it in different weather types and have it switch the strategy accordingly. Alright, so we've figured this out. You shouldn't care. Nah. Alright. Let's go ahead and commit this. Come back over to here and select a suitable entity. Let's commit that. Let's sync it up. Oh, kind of jumped ahead, but I want to get the example out there. So now in our strategy, we want to make sure that every strategy implements a few things. So we're going to say return, or we'll say suggest footwear. Suggest headgear. Suggest, I don't even know what. Suggest pants. Alright. Then clean this up. So coming back over here, let's get out of here. Let's return this. So in our outfit, we've got a strategy. We don't know or care what that strategy is comprised of. No, Angry Masturbator didn't miss much. I was just going over just the ramp up to our strategy pattern and picking a kind of nonsensical example, but hopefully it'll show the benefits before we get into the actual game application, the benefits of being able to switch things out at runtime and how powerful that can be. Alright, so I create an interface. Let's go ahead and just return null for that. It really is a pretty quick kata. Let's sync it. Alright, so the next one is going to be create stub methods for the various strategies to implement. Let's come back in here, and every strategy is going to have these 4 methods. So for footwear, we're going to return our outfit strategy dot suggest footwear. For public string headgear, let's return our outfit strategy dot suggest headgear. And then for string coat, return outfit strategy dot suggest coat. And for pants, return outfit strategy dot suggest pants. All right. So now, as far as being able to start modeling things out and get a system in place without knowing or caring what the implementation is going to be, the strategy pattern is also kind of earning its money. Okay, so all we have is a strategy interface, our concrete implementation, and the weather types, which are going to use to pivot which strategy we use. All right, so create stub methods. We did that. Let's go ahead and commit. Alright, so wire up the stub methods to a local iStrategy property. Okay, we kind of jumped ahead. I'm going to go back through and kind of refactor this kata because I think there's some more things we could enumerate as steps, but it really is such a short kata. It's hard to make it longer than it needs to be. Alright, so now that we've got our strategy kind of modeled out, the one thing we do want to do is create a for the interface. Okay, so the strategy pattern, and Ravi asked, can you explain why you use an interface? Absolutely. So the strategy pattern, all that it really suggests here is that we abstract out the implementation of our algorithms or our methods. And so this could be an abstract class that we use here. It really doesn't matter. The only reason why I went with an interface is because I think for the amount of understanding you need coming into a kata, it lowers it quite a bit. Interfaces are pretty straightforward. Class interface, you usually learn them together, while some of the inherent stuff with abstract classes comes a little bit later. What this allows us to do, though, is we can create a bunch of strategies that obey the interface contract without having to define them within the outfit class itself. And I will share that now, and hopefully the choice to use an interface will be clear once we see how we can satisfy the strategy patterns benefit of separating out the implementation from the abstraction. In this case, outfit is going to be our contract, it's our abstraction. Our actual implementation of that strategy, outfit should be ignorant to that. And we maintain that ignorance by using a interface or an abstract class, but again, we just decided to use interface. Alright, so wire up stub methods. Let's go ahead and do one of our last steps, which is code a few strategies. So add a new item. And I'm just going to call this outfit range strategy. And cut up a new one. Add new. And call this one outfit If I didn't do snow, I'll put that in there. Alright. So I'll make this a, oops, didn't make me an interface. I'll make it a public class, which will use the iOutfit strategy. So immediately ReSharper is saying, hey, in order to be compliant with this contract, you need to implement these 4 methods. I'll go ahead and let ReSharper implement the missing methods for me. I'll copy those, remove my unneeded using statements, come into Snow Strategy, make this a public class that inherits the iOutfit strategy, and go and paste those guys in. Alright. So now I have 2 strategies with nothing implemented, but they do conform to the iOutfit strategy interface. So to come back into my outfit, I need to have a way to switch out these strategies based off of the weather type at runtime. So I will do a public void set, just say set strategy, or just say set weather to really showcase that the API that we write and this abstraction away from our strategies doesn't have to match in wording or anything like that. So, and we'll take in a weather types of weather type. And then we'll do a switch statement on the weather type. There's a few ways to do this. I'm using the switch statement because it's very similar to what we did last week with the factory pattern. So if you're familiar with that, when you come over here, there shouldn't be anything new. You should be able to jump right in the strategy pattern and not lose time looking things up. So I'm going to do, I've got rain, and in this case I'm going to set our outfit strategy is equal to new rain strategy. I'm going to break. Do a case, weather types snow, which is our other one, and then I'm going to set the outfit strategy to a new snow strategy. I'm going to break, and my personal preference is for things we haven't implemented yet, if they fall through to the default, to throw a new not implemented exception. Alright, so, somewhat similar to the factory pattern in terms of us taking into a type and switching based on that type. Difference here being that we aren't doing it at instantiation and we aren't using it as a way to abstract out object creation. We're doing it as a way to change the behavior of an outfit at runtime. And we're able to do all these things, all this modeling, without having to, close that out, without having to write much implementation code. So as a design pattern and as an ability to model things out, again, we're getting that benefit of being able to test our model, to see it, and how it would work without actually having to commit much time writing actual code. Well, this is actual code, but without having to write a lot of business logic. All right, so looking good here. I'm going to go ahead and give this guy a constructor, because right now, outfit strategy, if you never called set weather, these methods would throw an exception because outfit strategy hasn't been set. So what I want to do is give it a public constructor called outfit. We'll have this take in a weather type, and then we'll set the weather immediately. In the case for the default constructor, we'll use the tip we picked up last week of the constructor changing. Oh, sorry. Ravi asked, do you need to renew the contracts? I don't actually know what you mean. If you can elaborate, we can definitely take a second and talk about it. All right. So for my default constructor, with no parameters, I'm just going to make it sunshine. All right. So now there are probably better examples out there for strategies. I want to pick something a little bit new. If you get the Head First Design Patterns book, they're going to do ducks and quacking as the behavior, and different ducks have different quacks. Pretty good. There's a variety of examples out there. This is, again, a pretty simple, pretty fast example of how we can change out this behavior. All right. So let's go ahead and just have it do something. Let's go back into our snow strategy. Oh, I'm sorry. There you go. You added set weather after you implemented it. Yeah. All right, so I added set weather after I implemented the classes. So set weather has nothing to do with the contract. And that idea of having things in this class that have nothing to do with the contract is what makes outfit an abstraction. So we're actually abstracted away from the implementation, which means we're abstracted away from any contracts, any requirements, any constraints. We're creating the strategy pattern as a way to affect the behavior of our application without having to know very much about it at all, which means we shouldn't have to know about the contracts. We shouldn't have to know about the implementation details. That's really the power of using these abstractions. And the concept of abstraction is going to be one that gets solidified not just in this design pattern, but in all of the behavioral patterns and quite a few of the structural patterns. So that's why we make a point here to do things like set weather, to say we're giving this ability to the application without needing to know much about it at all. Let's go into snow strategy, and we'll make this really simple. If it's snowing outside, we'll return you should wear boots. Return for headgear. Should wear a hat. Return and for the coat, all right, so typically this would be an algorithm. In our case, the simplest algorithm is going to be return a string. In other cases, like I was talking about the vehicles, where towing capacity for a truck could be affected by various things, that certainly would be an algorithm. And it'd be something that if you were doing it for, let's just say, an onboard computer in the car, if that was your design target, and you wanted to be able to tell the driver, hey, at any given time, calculate all these variables and let me know what my current towing capacity is, then that's going to be something that as soon as the user asks the question or submits the request for that information, you're going to pass in the current state or the current environment, and then decide in that moment what strategy to use to calculate the towing capacity. In our case, the application could be that it's a phone app and somebody says, hey, at any given time, I want you to take the current weather and tell me what I should be wearing. Let's go into rain strategy, and let's return footwear. And I'm going to remove the "you should" part of it. It's nice, but for the sake of being able to test this, we're just going to return back the name. It's nothing too crazy here, it's just code. Okay, it's a rain parka. Now obviously there's tons of holes in this implementation because there's tons of other variables you want to take into account. Maybe you have access to that person's wardrobe or whatever have you. So it's the simplest algorithm, so it's also going to be wrong 9 times out of 10. And we accept that. And we also appreciate it. Alright, build succeeded. Alright, so let's come back over to our abstraction. So just to go through what we've done so far, you've got a constructor that takes in a weather type and sets the weather. You have a default constructor that will automatically set the weather to sunshine if nothing's provided. When we call setWeather, we're going to run it through a switch statement, and depending on the weather, we're going to assign a different strategy. We didn't do a sunshine strategy, so that would throw an exception. So let's change that to rain. Okay. And then when the user calls our little outfit suggestion engine and says, okay, for this weather type, what kind of footwear should I wear? We're going to go to that strategy and have it run its algorithm and return the suggestion. Hey, killer. Thanks. All right, so let's go into our program and see what happens and see if this strategy pattern actually works. So one thing that we'll notice from this pattern that you're not going to see, that you would have seen last week in the factory pattern, is we didn't do anything for the creation. And as a result, we're not going to have that very clean factory interface we had last week. And it's good to see that here. We're really dialing in on the behavioral pattern. So it's going to make our creation a little, I don't even know what to call procedural, I guess. All right, so we're going to say var outfit equals new outfit, and resharper is going to go ahead and assist us with where to find that. Can't say enough about resharper. It's great, and once you start using it this way, you really do feel like you're in the dark when you go back to regular Visual Studio. I recognize that I'm doing you all a disservice because this is the one paid tool. So if you get used to seeing it here, you might develop a crutch for it. Alright, so as you can see, I can pass in no parameters or a weather type. Let's pass in rain for the sake of it. Alright. So let's go ahead and console.writeLine Thank you, Angry Masturbator. That's definitely the hope here. I'll do a small rant real fast, but the movement of do-it-yourself education, the idea behind like EDU punk and all that, Yeah, definitely. As programmers, we need to be empowering, our own base. And so, I know that there's a lot of people out there that want to learn. I want to teach. So here we are. You don't have to spend thousands of dollars on university when you've got a great community of fellow developers willing to help you out. And I get something out of it too. I guess it's the end of the rant is that part where by going through these lessons, I'm constantly reinforcing the design patterns for myself, and getting over the stage fright of being in front of the camera is also really good once I get back in the corporate world and I've got to defend my ideas and my architecture to my brethren. All right, so I'm going to go ahead and, for the console write line, make use of its built-in parameterization again, and say that blank the current weather condition is blank. And I'm going to go ahead and pass in So, inside of our outfit, we did not give access to the weather types, or what the current setting is. And to be honest, I don't think we should. It doesn't really place there. What we're actually going to do instead is we're going to say var weather is equal to our type rain. We're going to pass in weather into outfit, and then we're going to, for our console write line, say that the current weather condition is whatever we set weather to be. And I think I mentioned last week that ReSharper is wonderful and it makes a lot of suggestions, but the best way, the fastest way to learn is to grab it and then challenge and question every suggestion it makes, because sometimes they're needless, sometimes it's part of a deeper and more complicated topic. So here it's telling me that I could convert to constant, which I can, but the reasons why I should or shouldn't are pretty heavily contested and debated, so I'm just going to leave it alone for right now. Alright, and then I'm not going to do much in the way of a menu system or anything like that, but you can definitely imagine if you had loaded this application up and the person said, hey, suggest some footwear, and well, it knows what the weather is, so the recommended footwear is blank. I'm going to go ahead and do outfit, not footwear. Okay, so now we're at the first place where we can really put our strategy pattern into use. Let's say that 15 minutes ago it was raining, and so the current footwear suggestion was whatever that strategy said. If we say that the weather is now snow, and we call our outfit, and we say set weather to weather, then we can take this, copy it, paste it, and it looks very similar. So we got that consistency of code that we also had in the factory pattern in the creation, but now we've got it in a different spot. We've got that consistency of code and presentation in terms of the strategy and the behavior. So we didn't have to change anything except for the one condition on which the behavior pivots, and we can recall the same code. This becomes especially powerful when you need to create business logic that is uniform, concise, and doesn't change if it doesn't have to. So if this was encapsulated in a method, we could call that method without changing anything. We don't need to have different methods for different weathers, for for different weather types. We can just have the same method, and it'll pivot based off the strategy. All right. So I'm feeling brave. I'm going to go ahead and do a console.read key. I've never written this strategy before. This is my first time through the kata. I've never written this code before. So let's go ahead and see what happens if I try to build it. So that succeeded. And what happens if I try to run it? Okay. So I got an exception for it not being zero-based. I'm going to continue and exit that out. Where's my stop? Okay. My fault. Here in the parameters, it has to go 0, 1, 2, 3, 4. So what the compiler was complaining about was I gave it a parameter called 1, and there was no 0. So it freaked out. Okay. So stepping through here, we've got our suggested engine out right line, which is that first line. We had said weather is equal to weathertypes.rain. We had instantiated a new outfit, passing in the weather type. Then we had written out to the console, the current weather condition is blank, and the recommended footwear is blank. So what we get is the current weather condition is rain, and the recommended footwear is waterproof boots. And we have a read key. So we hit the button, and because I copied and pasted, I got this same thing down below, so let's fix that as well. Okay, start it one more time. All right, so the current weather condition is rain, recommended footwear is waterproof boots. I hit space, and I get the current weather condition is snow, the recommended footwear is you should wear boots, exclamation point. So a super simple implementation of the strategy pattern, but what it showcases is our ability to encapsulate algorithms into implementations that are separate from the abstraction. And I know that's a lot of words, maybe not even the best words, but it's when you look at the strategy pattern and you see how deceptively simple the examples are. For example, inside of my outfit, 50 lines of code, not a whole lot. If I come over to the one of the examples online, there's not a lot of code here either, but that betrays a lot of power that you get from using this pattern. So what I'm going to do now is I'm going to go ahead and commit this. Come back over to my code kata and code a few strategies, run application. Okay, and make this implement strategies and run application. Sync that up and sync. All right. Actually took longer than I thought it would. That's good. That's good. It means that there's places to optimize my implementation of the kata and places to practice as well in my delivery. So let's go ahead and close this guy out now that it's been synced up. Let's go ahead and open up our game. I feel like, I don't even know. Look, I made you take your medicine before we got to the fun part. That's mean. Okay, so if anyone was here last week when we implemented our game using only the factory pattern, we're still at that place, and we're making a zombie survival game. So let's go over to our command line. So we use the factory pattern to build out a player factory, an NPC factory, and behind the scenes, I got started on a few other things, and we demonstrated our factory kata in our command line application by creating a few players and showcasing how they might take damage, how they might heal, display their own names, things like that. So we created, in this one we created a player and an NPC. So that code is also on GitHub. Sure, Ravi. Inside of the channel, there's a link to my GitHub. And when you come to my GitHub, as the repositories, under repositories, there's going to be the strategy pattern kata. So let me grab this real fast. Oh, you got it. You're faster than I am with my tablet. All right, cool. Let's come back over to here. So inside of our game, oops, give me 2 seconds to write my tablet's world. All right. So with the 10 minutes we got left, my tablet decided to jump off a cliff. All right, here we go. 3 minutes left. We're going to look at making changes to our player, abstraction, which is a word we can use now because we all understand it, to use the strategy pattern kata we just learned about. So inside of my domain, you see that I've got quite a few things to find here: environment, inventory, monster, NPC, player. If you want to see how all this kind of came into being and all the reasons behind it, you can check out my highlights. And if I don't have my YouTube channel in a link down there someplace, I'll add that after we're done here. So inside player, I've got a player factory, I've got player types. And the player factory has a static create method that takes in a name and a player type and returns back a different type of, I would call them player classes. So what we want to do here is we want to change up the factory a little bit so that right now it's returning back this concrete implementation. It's returning back a new Army vet. And we don't want it to do that anymore. What we want it to do is we want it to return back player, because players are abstraction, and we want to make the types, Army, Vet, Carpenter, Mechanic, we want to make those our strategies. So we're going to do a bit of refactoring here. So we're still going to be able to return back iPlayer as our type, because that's our contract. So only thing that's going to change in our factory is going to be our little nitty-gritty implementation details. Let's get started with that. For better or worse, we're just going to go ahead and start applying the kata. We have already picked our suitable entity, which is the player. Let's go back over to this guy. Move list. Oops. All right. So we already have a simple UI. We're going to select and create a suitable entity. We already have that with our player. Now we want to create an interface for the strategy. So let's go ahead and say, what should it be? What should it be? We'll say player action. strategy. Alright, so we got our iPlayer action strategy. Now, if we look at our iPlayer interface from last week, we'll see that we can inspect, repair, and negotiate. So those are our player actions. Now, we're inheriting this interface from another interface called Actor. I'm not quite sure that I showed this last week, so it might have been an after hours refactor, so I'll talk about that real fast. I made the choice to make both players and monsters actors because they have a lot in common. And then I would inherit some behaviors into both. So for my iActor interface, I'm saying that anything that's an actor should be able to attack or move. Anything that's an actor should have these attributes: health, strength, intellect, wisdom, agility, willpower, charm, and endurance. So whether you're a monster or a player, you're going to have this set of stuff. So if we come back into, we go now into our base actor, I've said anything that inherits base actor will be of type base game object and also have to conform to the iActor interface. And I apologize, I should have mentioned the jump we're making from Kata into implementation. While the Kata is as kind of pared down as it possibly can be, when we get into the actual game, we are relying on quite a bit of object-oriented best practices, terminology, and approaches. So there's going to be a lot of abstract classes, a lot of inheritance, a lot of things that are going to help our structuring of the game. So feel free to ask any questions, or as we keep running through this, I'll try to get better about explaining things in a way that doesn't detract from our actual game time. Okay, so this is important to note because I've got attack and move. And those things are available to every player. So I do want them to also be a part of my action strategy. And I misspelled that. I'm just asking if I wanted to apply those changes throughout, and I do. Alright, so for my interface, I want every strategy to implement those things. Public, no access modifiers in my interface. Void attack. Void move. I'm just going to come over to my iPlayer for the rest. Copy those three things. Alright, so my action strategy for my player, for every player, is going to be these 5 things. So when I go over to my Kata, I create an interface. Now I want to create some stub methods for the various strategies to implement. I'm going to do that inside of the abstraction. Okay. So I have to refactor this just a little bit because I've got a player factory and it's returning these things. What I don't have is an actual player, which is what I want to return instead. Let's go ahead and add that. Make that a public class player, and we're going to have it inherit from iPlayer. And let resharper do its due. There's a lot here, right? So just to show how fast these things. Yeah. All right. Let's go ahead and bring all of that in, and hopefully we'll get through a lot of it before we run out of time. So a play needs to have all these things. We can shortcut quite a bit of this. And we're going to do that by looking at the way that we designed our other concrete implementations, like Army Vet. So Army Vet is really the kind of thing that we want here. So let's copy a lot from there. We've got a base player. Let's go ahead and undo that and change this to base player. A little better. Let's go ahead and copy over our constructor. Make public player. And that same constructor. We're going to run into a little bit of snag here. We'll fix that in a second. And as you can see, our Army Vet already does most of what we need. We're not going to remove any of this yet because we're going to change these guys into strategies. So this is the wonderful world of pattern refactoring. All right. So inside of our player is now our abstraction. So we want to add a few things here. We want to say that every player is going to have a public I player action strategy. Well, and we'll make that private. Action strategy. Following the kata pretty closely here. And because it's our abstraction, it's going to follow pretty closely, but it's not necessarily going to be exact. It doesn't have to be exact. So let's copy over all this good stuff. But now, instead of implementing these things here, we're going to ask our action strategy to return. Or not return, but to process. Oh, no heal, hang on. That's true. Alright, so a little bit of refactoring as well. Heal is no longer a real thing. Alright, so take damage and heal are actually two things that are part of our base game object that get inherited because they're a part of base player. So let's go ahead and add those to our strategy as well. Alright. Come back in here. Player. Let's keep refactoring. Remember, at this point, if we kept this as being base player, then it would directly couple with the implementation of the strategies, which we don't really care about, or we don't want to have happen because we're using this strategy pattern, which promises a separation of those, or a breaking of that coupling. So we make that I player action strategy instead. Let's see, do we have an inspect? No. So we're going to do quite a few things here to make this happy. So much refactoring. Okay. Let's inspect. All right, so can I go to Army Vet? Get rid of that guy because it's wrong. All right, so Army Vet's going to become our new strategy. And we had quite a few things inside of base player. Alright, so we don't really need this stuff anymore, which is part of the promise of the strategy pattern, which is to say, all the stuff that you thought you had to have, we can pack all of that into our abstraction, and you can get rid of a lot of that code. So let's go ahead and do that. So let's go ahead and bring player type, statistics, experience, and level. Into player. Oops. Did not mean to make that an iPlayer action strategy. I just mean to make it iPlayer. So now we can, that little red squiggly on player type goes away because we can now set that inside of our abstraction. Just going to move that. We're going to have this take from base actor and iPlayer. Set that. Set the name here instead. Oops. All right, use our constructor chaining, and we're good to go. So, refactoring is, we'll just call it never fun. All right, let's back up a little bit. Since we're using base actor, we're going to conflict with a bit here. Let's override attack. We're not going to jump in too terribly into why it's all in the code. We really just want to apply the strategy pattern as a way of refactoring what used to be apply the strategy pattern as a way of refactoring what used to be a factory pattern. Okay. So what else is not implemented? Let's just have resharp implement those. Take damage, heal, and move. That's fine. All right. We'll leave those as is. Okay. So now we're going to, I'll just start this off. Base player can go away entirely. We'll delete that. Alright. So, at its most basic, what we've done is we've taken what used to be a concrete implementation for every single player type, and we've encapsulated all of that in just the idea of player. What would have been different before, we're going to turn into strategies instead. So we'll leave this as it is right now. We'll come back into our player factory, and as you can see, now all these are wrong, right? Just to give an example of how this is going to be changed, what we want to do is inside of our player, in addition to taking a name, we also want to take in a player type. And we want to assign that player type here. And we'll set as a default as medic. And as a third thing, we want to take in a player action strategy. We want to set our private action strategy as being equal to the parameter that we passed in. And we don't really have one yet, so we can't really satisfy our default chained constructor. Does that make sense? Our default chained constructor? Maybe. Alright, so let's go back into Army Vet. There's no longer any such thing as a base player. We now want to instead implement the action strategy. So let's delete all this stuff that we would have had to do. And let's just go ahead and implement our missing members: attack, move, inspect, repair, negotiate, take damage, and heal. Whew. Okay, so it's feeling cleaner, right? Before we had to have concrete implementations for all these types. Now we don't. We have a strategy for every type, and we have one abstracted player where we're going to put all of, not all of our, but a good deal of our logic is going to rest here, and then we're going to put the granular complexity and all of that into separate places in our game. Okay, so I can now say that if I'm passing, oh, we'll do it, yeah, that's fine. So now I'm saying that if you just started up a brand new player and passed in no parameters, I'm going to just assign you as an Army Vet, and then I'm going to pass those values to my default constructor, and you're now going to be an Army Vet player with whatever that strategy says should happen when you move, attack, or do whatever. So it's looking cleaner, but we still got a bit of refactoring to do. So now when I say Army Vet, I don't actually want to instantiate a new Army Vet. What I want to do instead here is return a new player, pass in the name, return a new player, pass in the name, pass in the player type, and for this guy, well, I'm going to pass in a new Army Vet strategy. So as the first example of us refactoring, this is what it turns into. We're no longer saying player type carpenter, create a new carpenter. We're simply saying create a new player with that name, that player type, and make the strategy we implement the strategy for the Army Vet. Well, so we've gone a little over the hour-ish, or maybe we're right at the ish part of it. So the last thing I want to show, I'll spare you guys the junior level task of going through all of this and changing strings and calls and inheritance. That's just more applying of the kata, and it's good practice. But the cool part about this refactor, the cool part about using the factory pattern last week to create an API, and then this week refactoring out our player implementation to be an abstraction and apply the strategies instead, is when we come back into our program, nothing changed, right? So as far as the calling layer is concerned, our API didn't change at all. This is really important, especially when you're doing refactoring, or you're working in a team and you've put out or you've decided on an API that everyone's going to use, or you've created a game engine. You want to have the ability to go back behind the scenes, refactor your code, make changes, and not introduce breaking changes to the team, or not create a headache for yourself. So this is a little success here in terms of being able to improve an aspect of the system without breaking another part. So let's let's go back into our player. Just give a quick look over what we did. We introduced the idea of a player action strategy. We brought in a lot of the code that was otherwise in the concrete implementations of things like ArmyVet. We brought it into the central place. So now all ArmyVet cares about is implementing those strategies. It's more focused. It's more in line with how we want the game to operate. We want the idea of player to be something different than the idea of class. And while we might rarely change the player's class, you can see that concept of like a reroll or a restart, where you want the player to stay the same, but if they restart, give them the option to change out their class, but retain 2/3 of their experience. And this is how we'd accomplish that, by making the player an abstraction, by making the things that that can be changed these separate implementations. And just to show that refactoring one more time before we head out, I'll go into Carpenter. And Carpenter is no longer a base player, and let's go ahead and remove all of this. And call it a player action strategy. And let's go ahead and implement. Alright. We haven't really decided what these things mean, but it doesn't matter. This is again the power of the design patterns. We can begin to model out our game and proof out the design without having it stuck in the weeds of the implementation details. So we go into factory. Just going to copy this over and change ArmyVet to new Carpenter. And let's go ahead and while we're here, do that, and that. All right. I'll accept some red squigglies for a second. Let's go into our mechanic. Is that next? Yes. Let's remove everything that would have made it a base player before. Again, remember, base player is gone completely. We transferred base player into the player abstraction. And we turn mechanic, or what should be a mechanic, into just a strategy. Okay, so now that we've seen it twice, I'm just going to go ahead and copy all of this and do it a little faster in Medic. Just going to replace all of that with that. And in Politician, replace all of what would have been the base player contract with now the strategy. Okay. Let's go go back into our player factory and new mechanic, new medic, new politician. Alright, so what did this really buy us? It brought us, quite a few things. Not going to belabor the things we've already talked about, but if we wanted to try this out now, let's go ahead and get rid of our base actor. And let's go ahead and let's close player. Okay. We've got a few things we're not implementing quite yet, which is fine. Let's go ahead and wire these things up because we do have them. Alright, so just like we saw in our outfit, the same way that outfit was the abstraction, player is now the abstraction. It takes in base player, it takes in I player, but then inside of our factory, we never cared and we still don't care what this does. The factory is really, it's agnostic to the creation or the implementation of the object. It's just providing a way to cleanly create new players. And we see that when we go into we see the benefit of that when we go into the program, and again, nothing's changed. Okay. So we build and succeeded. What happens when we play this now? Because we changed a lot of code. And there's a good chance we fat figure something or something's not going to work, right? But we had this basic example of the factory pattern before. Let's see if that still works. All right, Morgan says hello. It brings you to this place. And that's a result of Morgan, who is a non-player character, a townsperson, is being greeted. I'm going to read the key. All right, and so we come down and we want to see, and so we wanted to see how many hit points Morgan had and what type of NPC she was. And so he said Morgan's a townsperson. She has, or he has, 100 hit points. We then called Morgan's take damage, and Morgan took 13 points of damage. And then we outputted again that Morgan is a townsperson. She now has 87 hit points. And we said that Beth, who we defined earlier as a medic, moves to heal Morgan for 20. And Beth heals Morgan for 20 hit points. Morgan is a townsperson. She now has 107 hit points. Alright, so we had a pretty procedural game going before. And what we want to do tomorrow is take about an hour and start seeing how we can encapsulate this heal amount into the medic strategy. So we're going to start putting those behaviors into practice and then applying it to our very rudimentary procedural console game. And so that's pretty much it for today. I think we've done a lot and we're a little bit over time, but this should set us up for a good day tomorrow. Hey Ravi, thanks for hanging out for the whole thing. I'm going to go ahead and pull these YouTube videos, convert them over, and stick them online. Again, if the YouTube link isn't in the channel yet, I'll go ahead and put it there. If not tonight, then tomorrow. And if you want to come out tomorrow as well, we're going to be getting into the nitty-gritty of really just applying the strategy kata and putting in some behaviors and just seeing how that works. And about as close to the real world as we're going to be able to get. All right. Thank you, everybody, for hanging out, and that's it.